There's a bunch of working answers at the beginning there if you just want to see that before we get started. For part A, you're supposed to do a slope field. So it gives you a derivative there. And it's nice they only give us 6 points instead of 12 like they sometimes do. But it helps me to just write down those 6 points. And I just take those numbers for the x and the y. So I'll take 0, plug it in for the x, take the 1, plug it in for the y. Gives me my slope as a -1. So I do that for each one of the points. If the slope is a +1, I just kind of, make it like that. If the slope is a +3, I have to make that steeper. So it's all relative. This had a steeper slope than that one right there. Then the negatives make them going downhill. Horizontal, the slope is equal to 0. So you got part A down. Part B, this notation means we're about to take a second derivative. So I need to do the derivative of this. So the derivative of 2x is going to be 2. The derivative of y is y prime or a dy dx. So it's like or the derivative of y is 1, and we're tagging on that y prime or the dy dx. So I do the derivative of that first derivative. So I'm going to get 2 minus the y prime, which is 2 minus dy dx. Now, since it states in terms of x and y, it means it doesn't want the y prime there. You have to get rid of the y prime or the dy dx, and you just substitute what the dy dx is equal to. So just plug in the 2x minus y for that dy dx, and you can kind of stop right there. You can distribute if you need to, but there's that first part of that. So I thought that first part of part B was kind of simple. The second part, though, I had to think for a little bit. It says determine the concavity of all solution curves for the differential equation in quadrant 2. So that's what we use the second derivative for. I was staring at the second derivative, and okay, I wanted to figure out if we're going to determine whether something's concave up or concave down, we got to figure out whether this expression is positive or negative. And it's kind of weird because they don't really give us any points, except the only thing they give us is in quadrant 2. So I said, okay, let me think about my x's and y's in quadrant 2. In quadrant 2, I know x is a negative value, y is a positive value. And so if I go to this guy right here, I have this 2 minus carries down. If x is a negative number, that means I have 2 times a negative number, which is going to give me a negative number. And then you're minusing a y value, which is positive. So you're minusing a positive number. So 2 times a negative number is a negative. You're minusing a positive number. So if you take a negative number and subtract a positive number from there, you're still going to have a negative number. And then your 2 minus carries down. So 2 minus a negative is always going to be 2 plus a positive, which means that second derivative in that second quadrant is always going to be positive, and that means your solution curves will be concave up right there. So you just got to use your brain to kind of think about that a little bit, but try to just be cement. Be like, all right, the only thing they give me is in quadrant 2, so you know what your x's and y's are in quadrant 2, so then start plugging some stuff in and think about that. And they have to give us something where we can determine whether that's going to be positive or negative. They got to make that work out for us somehow. All right, now letter C is talking about this particular solution to the differential equation. Now, normally, if they tell me to find the particular solution to a differential equation, that's when I'm going to integrate both sides. I just want to mention right away at the beginning here, if you try to find the differential equation like we've done on so many other problems, if you move that dx over there and it looks like this, you cannot do any legal algebra to separate the y's with the dyx's with the dx, all right? Like the only thing you can't like plus y there and plus y there. It doesn't make any sense because it's in that parenthesis. Like if you have 5x minus 4 times 15y, you can't like add 4 to both sides of that equation right there. So you're not allowed to do legal algebra, just like add y to both sides. If you divide both sides by the 2x minus y, then you got 1 over 2x minus y dy, but then you got the x's stuck with the dy. So there's no legal algebra that we can do to separate those variables, which means if you can't do basic algebra to separate those variables, you're not meant to. Okay, that is a whole nother class in college called DiffEq, called differential equations. You could solve those differential equations, but involve substitution techniques and different techniques that's not on our AP test. That's beyond the scope of the calculus thing there. So if you can't separate your variables easily, don't do illegal algebra and just make up your own stuff there. You're not meant to. And notice it doesn't tell us to find that particular solution. It just says, okay, we have like this original function, and we just want to know, does it have a relative max, a relative min, or neither at the x equals 2 right there. So we got to think about what makes something have a relative max or a relative min, right? That's where like the first derivative is equal to 0 and change its sign, or we can use that second derivative test. Second derivative test tells us if our first derivative is 0 and our second derivative is positive, we got a relative min. If our first derivative is 0 and our second derivative is negative, then we have a relative max. You can look at that again on your blue packet if you need to. But to be a relative max or min, the first thing we got to have there is that first derivative has to be equal to 0. So I took x equals 2 and I plugged in x equals 2, into that first derivative. Now it gives us, we have the point 2 comma 3. So when x equals 2, the y is equal to 3, which I need both things there because my derivative has x's and y's in it. And so I plug the 2 in for the x, plug the 3 in for the y, and got my derivative is equal to 1. And then so when I got 1, I was like, well, if my derivative is equal to 1, that means it can't be a max or min, right? Your graph has to level off right there. You have to have a horizontal tangent line to be a max or min. If your derivative is equal to 1, that means your function is going up. It's increasing because your derivative is positive. You have a positive slope there. So it's neither a max or a min since that derivative is not equal to 0. So it just kind of ended the problem right there. It was neither at there. Now, let's pretend for an instant. Let's do a little extension of that problem. If that derivative was equal to 0, what I then would do is go to that second derivative like that we found in part B. I would go to that second derivative and I would plug in that point to that second derivative and try to determine whether the second derivative is positive or negative. And then if the second, well, actually we already know it, that actually no, so you would go to the second derivative and you would try to apply your second derivative test. Like if you know your first derivative is 0, and if your second derivative is positive, then that would be a relative min, right? If your second derivative is negative, that means your graph is concave down, forces that to be a high point right there. So that would be a relative max. But it didn't ask for any of that, but that's what you do if I did get 0 for that first derivative. Okay, now letter D, I got 2 ways to work out this letter D. You probably came to the video just to see letter D worked out. Down here was my first thought on this problem. I was just kind of trying to jam this puzzle piece to make this thing fit somehow. And then a second thought of mine was to kind of worry about this stuff right there. But this wasn't my first thought on this problem there. So let me just start. This is the most efficient way to do it though that I can think of. All right, so letter D says find the values of the constants m and b where that y equals is a solution to that differential equation. Now, if I start with the y equals mx plus b, notice that that's a line right there. That's a linear function. And so the second derivative is always going to be equal to 0 because a line doesn't have like concavity right there. But if you take the first derivative, like if you have y equals mx plus b, your first derivative would be m. And in your second derivative, you're doing the derivative of a number, which is always going to be equal to 0. So if you recognize, hey, I have a line right there, and my second derivative is always going to be 0, then you could just take that second derivative, set that equal to 0, and then boom, you could just solve that for y, and then boom, you got your m, you got your b, and that's what they're asking for is the m and the b. Now, you're probably worried about, oh, I don't know if I would have thought to do that, okay? So, you know, the point is like if we're working hard on A through C, we're going to have all those points already. If you're going through this test and you're getting, you know, most things as you possibly can, it's not the end of the world if we get stuck on a letter D or something like that, right? You just get as many as you possibly can. Some of those letter Ds you're going to get, some of them you're going to struggle with there. You just do the best you can, try to get something down, and then move on. Make sure you get through the rest of the test. Here is, in letter D was like we're 3 points out of the 9. So if you got A through C, you got 6 out of the 9 points already. Here is another option that I was saying. When I first saw y equals mx plus b, I said, okay, m is my slope. And you know what else is the slope? Is the derivative. So what I'm going to do is set the slopes equal to each other. So I'm going to set m equal to my 2x minus y because I'm setting those slopes equal to each other. Now, if you just think to do that, I checked the rubric there. They awarded 2 out of the 3 points just for knowing that the slope is the derivative, all right? And the derivative is slope. And then to do the rest of this, I was kind of like jamming this puzzle piece to make this thing fit there. But I took, what did I do? I took that y equals mx plus b, and I plugged that in place for the y. And I just tried to get everything on one side, and I was able to factor out an x. I was able to factor out a b. It wasn't really factored by grouping or anything here. All I was trying to do, like, I know there's more solutions than this, but one way to make this equation equal to 0 is if that is equal to 0, because I have 0 times something, and if that's equal to 0, because then I have 0 minus 0, which is equal to 0. So I realized there's more solutions than that, so that's why this was a little bit weird to me when I was first working this out. But I was just saying, okay, to make this equal to 0, I know one possibility is to make both of those equal to 0. So I was just trying to make that puzzle piece fit. So I set both of those parentheses equal to 0, and that also gave me the m was 2, and that b was -2 there. So that letter D that was a real tricky problem, you know, but we'll make sure we're perfect with all the other stuff. If we get some of those tricky ones, you know, we'll be good there. But if we struggle with some of that, you're going to get the rest of the test. We're going to be all right there. TI 84 plus big.